Hello everyone, welcome back to next video lecture. In this video lecture, we will focus on electroplating and electrorefining, right? So, electroplating and electrorefining is related to electrolysis in electrochemistry. As in the previous lecture, we have discussed about electrolysis in electrolytic cell. So that is a central or focus theme in electrochemistry, right? So electroplating, first thing is that what is electroplating and how this works. It means we are trying to focus on the mechanism of the electroplating through the use of electrolysis, right? Or simply you can say uh, an electrolytic cell, so that is used to establish the function of electroplating, right? So electroplating means just it is a in process, right, based on electrolysis, where a thin film of metal is deposited onto other metals, right? So electroplating, once we come across electroplating, it means first what are the structure and components of the electrochemical cell, so that will create electroplating phenomena. So let us try to understand the functional component and complete setup of the electrolytic cell that is used for the electroplating, right? So electroplating is the most important phenomenon or process that is used to coat or deposit most important, or simply you can say the metals uh, over a another metals, right? So what happens here is that here three main component is required. As in the previous lecture, I have given an idea about the electrolytic cell, so which contains cathode, that is cathode, and second one is anode, right? And third one is electrolyte. So these are the three components which required to construct the electrolytic cell, right? So in this electrolytic cell, what happens actually? We need two electrodes. Suppose we have a metal electrode, so that is desired metal on which we want to coat or deposit a desired other metal, right? So, and that is act as cathode. Another thing is that the next electrode, that is anode, which is actually composed of the pure metals, right? Uh, which is used for coating purpose. Suppose in case of deposition of copper or copper platings, so the second electrode, that is anode, is copper strip, right? So it is pure copper strip, and it is any other metal strip on which we want to deposit or coat the copper metals, right? So it is a process to deposit or coating the desired metal with respect to high resistance or highly inert metals to protect them, right? So in this container, actually we have a copper sulfate solution, right? So the copper sulfate solution is acidified with H2SO4. So it means H2SO4 enabled copper sulfate solutions, which is composed of copper 2 plus, right, and sulfate as a anion in the electrolyte medium. So electrolyte contains copper 2 plus aqueous and sulfate 2 minus aqueous, right? So in this solution, we just dip these two electrodes, means cathode, the desired metals strip which is dipped, and anode, the material or the metal which is sought to be deposited on cathode, is dipped into this particular kind of electrolyte. Here copper is the pure metal which is actually deposited on the cathode. So here solution is just copper sulfate. So when a metal is dissolved in its salt, right, so it creates a potential, that is electrode potential, right? So these two electrodes are dipped into the same solutions, right? So here this is your M. M is any kind of metal which is highly reactive, and we want to uh, make it inert, right? Or I want to make it inert or try to prevent from the corrosions. So we just if you coat another metal that is less reactive and corrosion preventive, so then this electroplating phenomena is significant. And the electroplating is actually based on electrolysis. So electrolysis means there is a anode and cathode, so which are dipped in a particular electrolyte. So anode is responsible for oxidation. It means metal can be oxidized or metal can be dissolved and it will go into the solution, right? So in the cathode part, so metal can be deposited, right? So the materials or metal which is deposited, they come from the anode. So here the metal which is actually required to deposit on cathode should be dipped in this solution, right? And these two electrodes are externally connected by a source of electricity, right? So this is actually battery. When switch on is carried out in this battery, what happens? The negative pole of this battery, right? Negative pole of this battery is connected with cathode, and positive pole of this battery is connected with anode. Now when switch is on, then this metal strip, so that is cathode, is actually gets negative charge, and the anode which gets positive charge. So there is a potential difference between these two strips, right? So or you can simply say there is a potential difference between these two metals strips, right? So this potential difference actually set up a electrochemical cell, and this electrochemical cell actually creates a electromotive force, yani electro potentials, or you can simply cell potentials of this particular kind of electrolytic cell. So electroplating is nothing but it is a kind of electrolytic cell, right, where electrolysis can take place. So now once these two electrodes are connected through the external source of electricity, and it means battery. If switch is on, then electric current flows uh, in this medium, electrolyte medium. Now what happens? Some electrons from anode to cathode is transferred, right? It means this cathode is negatively charged and this anode is positively charged. Now, if the current is sufficient between these two electrodes, then what happens? Some copper metal gets dissolved as Cu2 plus. It means some copper dissolved as Cu2 plus, right, from the copper strip. Now this copper 2 plus came into this particular electrolyte, and this copper 2 plus will try to reduce onto the cathode because of the potential difference between these two electrodes. So what happens? This Cu2 plus reaches to the cathode which is negatively charged, and by receiving the electrons from the metal surface, they gets reduced. It means one Cu2 plus plus 2 electron, and then it is converted back to copper solid, and this copper solid ultimately gets deposited around the surface of cathode. It means the mass of the cathode increases with time. So because current is passing continuously in this circuit, so as the time passes, copper 2 plus ultimately gets reduced at cathode and deposited as a thin film around this particular kind of metal, right? So the mass and weight of this cathode increases with time, but the mass of this anode, because some copper atom gets dissolved in electrolyte, so mass of this anode gets actually decreased, right? It means it becomes thinner, it becomes lighter, right? So it becomes thinner or lighter, while this cathode become thicker and heavier with time, and it means the copper gets deposited on the surface of this cathode, right? So what happens at the anode side, right? Copper gets oxidized Cu2 plus plus 2 electrons at anode, right? So copper is oxidized, means copper undergo as a copper 2 plus into the electrolyte solution, right? So here there is a positive charge on the surface of copper, so sulfate ion naturally try to approach and neutralize this positively charged structure. So sulfate ion from the solution continually approaches to this positively charged surface so that it maintains the neutrality of the composition, right? And copper 2 plus approaches towards cathode. It means you can say that both cations and anions, they are actually traveling opposite to each other to maintain the electroneutrality of the solutions, right? So as you know that once a metal electrode is dipped into its salt solution, then there is a potential developed on the surface of metal, so it is called electrode potential. And if it is carried out at 1 molar concentration electrolyte, 1 atmospheric pressure and 298 Kelvin temperature, then it is called standard electrode potential. So E and E naught, right? This is standard electrode potential, this is electrode potential. So cathodic potential and anodic potentials, so they are generated and they will try to construct a electrolytic cell, and the resultant potential is, that is, E cell is equal to E cathode minus E anode. So this is the electro potential of the cell, that is standard reduction potential of the cathode minus standard reduction potential of the anode, right? So this is the process by which any other metal can be coated or deposited by a particular kind of another metal from the anode. So anode is responsible to act as a donor of metal, so that is required to deposit on the cathode. So here cathode is a receptor or acceptor of the anode metals, so it is deposited. Okay, so just it is getting thicker and it is getting thinner. So this is what we call it as electroplating. Electroplating means कि some important anode metal is getting deposited or plated on the surface of the cathode, right? So why electroplating is important in the electrochemistry? Actually, this deposition or plating will actually creates various significant properties in the overall resultant metal. So if you suppose, if you want to prevent it from corrosions, sometimes we have a iron metal, so actually it is getting rusted in the moisture or air moisture because of the formation of rust. So if you want to prevent it from rust, we just actually try to electroplate on this iron so that it becomes inert towards moisture or air moisture. It means we are trying to deposit or coating the iron surface with high resistance or corrosion resistant metals. So this is the process by which we can electroplate the cathode materials, right? So this is the actually example of deposition of copper metal on the cathode. So here we have used copper sulfate solutions. If you use zinc metal, then you will try to use zinc sulfate solutions, right? So electrolyte solution actually must be selected in such a way that the anode metal can gets dissolved in the particular electrolyte. So this is the actually process by which copper gets dissolved into the solution, and this is ultimately reduced at the cathode and deposited as a thin film around the surface of this cathode. And this process is actually electrolysis. Electrolysis means anode is responsible to oxidation and cathode is responsible to reduction of the copper 2 plus. So this is what is the electroplating. Now electroplating, suppose we just want to coat silver. So it is used for coating cutlery jewelry. In the jewelry industry, we have low quality or low price jewelry, and if you want to uh, give it sign and mm, properties like a high quality or high cost jewelry, then this electroplating process is beneficial for improving the quality and cost of the low cost jewelries. So if you want to deposit or coat the silver on a cutlery jewelry, then we must follow the mechanism of electroplating, right? So this is the actually cutlery jewelry. Now another one, if you want to deposit gold or if you want to coat gold, so it is actually some electronics devices or simply jewelry. So then the gold electroplating process must be performed, right? So another thing, if you want to plate nickel such as on tools, right, or utensils, so kitchen wares, so if you want to coat nickel, so nickel is actually corrosion resistance, so it has high capacity to resist corrosion, and it's actually improve the surface property, or it increases the shining of the tools or utensils, so it is used as a electroplater. So it is electroplated on tools and utensils. And zinc is electroplated on iron or steel, because zinc is corrosion resistance, right? So in the electrochemical series, zinc is below than the iron and steel. Steel is some alloys, so here in comparison to iron, so it is kept below, and the below metal is actually highly inert or corrosion resistance, they are not reactive. So here zinc is used as a electroplating for the iron surface. Now next one is the chromium. So chromium is actually used to electroplate the automobile vehicles, etc. So in the industry level, there is a great demand of most important significant metals, that is for the electroplating to improve the surface property, right? So to improve the surface property means, so if you want to make the surface conductive or non-conductive or semiconductor, then accordingly the materials or metals can be deposited on the particular surface which we want to deposit, which we have, right? So another thing, for the protection purpose, right? So if you want to protect the surface, the materials which is actually we have, so this process is very much significant. Another one property is corrosion prevention. The most important actually techniques follows the electroplating, that is corrosion prevention, right? And if you want to make surface as abrasive, right, and shining, then we must follow the mechanism of electroplating. So electroplating has broad attentions in the industry level, or you can simply say in the electrochemistry. So in the general daily life, what applications actually based on headphones, actually it is nickel coated, so it is always deposited with nickel. And mobile connectors, so this is AU plated होते हैं, right? And kitchenwares, some kitchenwares in the home actually they are silver or gold coated. So everywhere coating is important, and coating in the sense it is in the form of thin film. So thin film has actually enhanced properties, right? So this is the process by which we can actually try to explain the electroplating, right? So now what are the possible industries where electroplating uh, take plays an important role? So it automobile industry is the most important industry where electroplating techniques is most significant and used to create the surface passivations or surface activations, right? So ship air space, or you can simply say aerospace technology, has actually a very big role of the electroplating, and this is some electronics and electronic devices, they are also uh, processed through the electroplating. So because if you want to increase the efficiency and function of the electronic device, so we must have to electroplate the uh, internal or external surface of the parts, right? And most important in the jewelry industry, where electroplating has increased the cost of low cost jewelry, right? So because if you have a copper jewelry, and if you want to increase the shining of the surface like gold, then gold electroplating must be performed before launching that kind of jewelry. So electroplating actually electroplating has big role, right? Big role in industry, industry and electrochemistry, right? So this is electrochemistry. And electroplating is just it is the application of the electrolytic cell, or it is the application of the electro uh, lysis, right? So electrolysis is most important in the electrochemistry, right? So this is the actually process and the possible applications of electroplatings, right? Now we come across electrorefining. So this is electrorefining. What is electrorefining and how it is different from electroplating? So that can be illustrated beautifully in this page, right? So electrorefining means we are trying to refine the metals, right, from alloys or ores, right? So just it is, in another words, it is the extraction or purification of the metals. It means if you have a impure metals, impure metal in the sense it may be alloys or it may be ores which contains different metals. Suppose we want to extract gold, then if you have a ores of gold, then it contains silver, aluminum, iron, zinc, lead, SN, etc. So many metals can be actually uh, constituted to the impure metals. So if you want to extract pure gold from the impure metals, then this process, this is electrorefining, and electrorefining is an electrochemical process. So that is based on the electrolysis, right? So where pure metals can be extracted or purified, and it is ultimately deposited on the cathode, right? So here again this is a kind of electrolytic cell where three central components are required, right? So as in the case of electrolytic cell, or in case of electroplating uh, cell, uh, similar to that, we need cathode, right? We need cathode and anode, right? And one central thing is electrolyte, right? So this is your electrolyte. So electrolyte is a medium for uh, ion transfer, right, at the anode and cathode respectively. Okay. So here what happens? How this cathode is actually developed? In electrorefining process, cathode is made up of pure metals, right? High quality pure metals. Suppose in case of copper electrorefining process, so it is actually made up of pure copper. So cathode is actually pure. Actually, this is pure copper. This is your actually cathode, and this cathode is actually pure copper. So this is your mistakes. So this is your pure coppers, and the anode is impure, right? Impure copper. Impure copper means it may be alloys or ores, right? So which contains copper atoms, and apart from copper, another metals like lead, tin, iron, zinc, so etc. other metals can be constituted to create impure copper. So impure copper strip is actually developed as anode. So this is your anode, and suppose we want to extract copper from its ore or from alloys, then we need to develop or construct a copper strip, that is pure copper strip. So cathode is pure copper strip and anode is impure copper strip. Now these two electrodes are dipped into the solutions, and if the electrodes are actually uh, from copper, so the solution should be copper sulfate, right? So it is acidified with H2SO4, right? So H2SO4 acidified copper sulfate solution will act as a electrolyte. Now this copper sulfate solutions has Cu2 plus and SO4 2 minus as ions in the electrolytes. Now what happens? These two electrodes are once dipped into the electrolyte in the container, and finally they are connected externally through the source of the electricity, or you can simply say if you connect these two electrodes through battery, right? And similar to the electrolytic cell, the negative pole of the battery is connected through the pure copper electrode, right? And positive pole of the battery is connected through impure copper electrode. Now if the battery is on, then the cathode gets negative charged and anode gets positive charged. Or if there is a potential difference between these two electrodes, then charge transport takes place, and the charge transport means electrons transported anode to cathode, right? So electron always flows from anode to cathode. It means cathode is getting negatively charged and anode is getting positively charged, right? If electricity or current continuously flowing through this circuit, then what happens? From the impure copper electrode, right? So actually this impure copper electrode or copper alloys are dipped in the copper sulfate solution. So like dissolved like phenomena, some copper atom gets dissolved as copper 2 plus. So it is actually coming from this strip as copper 2 plus, right? And the soluble metal which are present in the impure alloys or ores, if it is soluble, then it is soluble impurity go into the solution, right? So only copper 2 plus come into the solutions and all the impure soluble metals also go into the solution, right? So what happens? And there will be some insoluble impurities. So these insoluble impurities may be deposited at the bottom of the container, right, towards anode. So here this kind of uh, impure materials are deposited in the bottom. They are called anode mud, right? So here we just want to correct the diagram. So in the anode side, impure metal which are insoluble in the electrolyte, they gets deposited in the bottom of the anode side, while those metals which are soluble impurities, they are trying to uh, go into the solution of the electrolyte, right? Now there is a potential difference between these two electrodes. So what happens? Copper 2 plus from the impure anode metal strips, it come across cathode, right? And cathode is a rich source of electrons. So ultimately copper 2 plus receives electron from the cathode surface and gets reduced back into copper solid. So what happens? Copper 2 plus from the solution, right, receives 2 electron, then it is converted back to copper solid. And this copper solid is actually deposited around the surface of the cathode, right? So around the surface of the cathode of the pure copper electrode. So this is pure copper electrode will receive only pure copper, and that copper is actually coming from the impure anode electrodes. So in this way, the extraction of the copper from impure copper electrodes or from the alloys are extracted through the electrolysis, right? So after the passage of time, what happens? The weight of or mass of this particular kind of pure copper electrodes getting actually increased. So this becomes thicker or thinner, right? So because of the deposition of the copper, and those impurities which are insoluble in the electrolytes, they are getting deposited in the bottom, right? So they are called anode mud or anode sludge, right? So what happens here? Copper 2 plus actually coming from the impure copper electrodes. So this is actually anode, right? So from the anode, copper gets dissolved as copper 2 plus by releasing 2 electrons. So this is the oxidation process, right? So at anode, it is actually oxidation. Copper gets oxidized into copper 2 plus. Now at the cathode, where pure copper strip acts as a cathode, actually it is a rich source of electron. Now the oxidized copper 2 plus will ultimately reach at the surface of this cathode and gets reduced as copper solid, right? So ultimately this is reduction reaction. So reduction favors at the cathode and oxidation is favored on the anode. So this is the process of electrolysis actually, and this electrolysis actually responsible for the extraction of metals which is desired from the alloys or impure metals, and it is ultimately purified. And some important metals can be extracted from this anode mud, right, which is actually deposited in the bottom of the container through a particular process, right? Or again by constructing a different kind of electrolytic cell from which we can extract different metals from this sludge, right? So this is the actually process of electro refining, which are based on the electrolysis of the actually metal, right? Now similar to the copper extraction or purification, so this process can be utilized for silver extraction and purifications and gold extraction and purification process. So it is most important and significant techniques, analytical techniques. So that is used for the extraction and purification of the metal from ores or impure strips, right? Why copper is extracted or purified from impure copper electrodes or from copper alloys? Because if you extract copper in a pure form, so it has a various role and various applications. So because of the improved properties of the copper in a pure form compared to the impure form, so in case of copper extraction, it has actually high electrical and thermal conductivity, right? The copper which is electro refined from impure copper metal or impure copper alloys, then finally we will get a very high electrical and thermal conductivity. So that can be applied everywhere in the electronics or electrical engineering. The second actually advantage is that it can be molded easily, right? So pure copper can be molded and can be folded or can be stretched as wire. So that gets beautiful actually benefits. And the most important advantage is that uh, it creates low toxicity, right? So once copper is extracted or it is purified from the copper alloys, then the finally it has low toxicity compared to the impure copper alloys or ores. And one another good benefit is it is good conductor, right? So this is the actually benefit of the extraction and purification. And next one is the corrosion resistance. So it is corrosion resistance. So it protects from the corrosions of the iron or any other kind of material that is easily rusted from the moisture or atmosphere. So electrorefining process are actually used to uh, prevent the corrosion of a particular kind of metal. And good soldering properties, right? So the copper which is extracted from the alloys have actually good soldering properties. So it is actually used in soldering process to connect the two pieces of the actually metals, right? So similar to the copper purification and extraction, so many metals can be extracted from the alloys or impure ores like silver. So silver can be extracted, or gold, or nickel, or lead, or antimony. So these are the metals, or a lot of metals actually that is used for the extraction and purification purpose. So if we have a copper impure metals, then it can contain silver, gold, nickel, lead, and antimony. So from these 5 metals, copper must be extracted, and the copper which is extracted must possess these properties, right? So now this is what. Similar to the copper extraction or copper electrorefining, so AU, that is gold, gold electrorefining process can be performed, and in this process SCl is electrolyte, right? So SCl is electrolyte because AuCl4, this is overall that is 3 minus. So tetrachloro gold, this is a complex, and this complex have capacity to dissolve gold ion. So that is why the electrolyte is also selective, and it should be chosen in such a way that the metal which is extracted from the ores, that should be dissolved in the particular kind of electrolyte. So what actually happens at the cathode, copper in the first oxidation state gets reduced by receiving just one electron from the cathode in the gold, and that is AU. And AU gold gets dissolved on the from the anode by just releasing electron. So this process occurs at anode, and this process occurs at cathode. So in case of gold extraction and purification process, so these kind of Hobson's reactions actually occurs and set up a electrochemical cell in the electrolytic cell, right? So depending on the nature of the metal which we wish to extract and purify, we need electrolyte, so that actually dissolve it from the anode, right? So in case of silver extraction, Ag extraction, similar to copper extraction, Ag extraction requires HNO3 as a electrolyte, right? So that is actually nitric acid, because silver is soluble in nitric acid, yani it forms AgNO3. So AgNO3 silver nitrate is soluble, right? So that is why this kind of electrolyte is chosen here for the extraction of the Ag. Now, once the electrolytic cell is set up, then and battery is on, and continuously electricity is passing through the reaction medium, then potential difference will create some oxidation and reduction reactions. So at the cathode, silver first gets reduced into Ag0, just receiving electron from the surface of the cathode, and at the anode, so this is your cathodic reaction and this is your anodic. At the anode, silver gets oxidized, or it means silver atom gets dissolved into the nitric acid. Now this is the process of reduction and oxidation between these two electrodes, and these reactions are responsible to set up a electrolytic cell, and electrolysis are actually generated, and electrorefining process accordingly achieves. So similar to the copper, gold and silver, if you want to extract zinc from the ores or from the alloys, then it should have a solution zinc sulfate, which is acidified with H2SO4, right? So H2SO4 actually added to prevent from the hydrolysis of zinc 2 plus, because zinc hydroxide is white precipitate. So this H2SO4 actually reduce the hydrolysis of zinc 2 plus. So zinc 2 plus and sulfate 2 minus are actually existed in the electrolyte. Now, once the electrolyte and impure zinc electrode is actually available, then we can set up a electrolytic cell by constructing the cathode of pure zinc strip and anode with zinc alloys or impure zinc materials. Now what happens here? Again electrochemistry is applied and oxidation reduction takes place. So at anode, zinc gets dissolved and it is coming into the solution as zinc 2 plus, right? So ultimately at the cathode, so zinc 2 plus will receive 2 electron, it's converted back to zinc solid, right? So this is the process and electrochemical reactions at the cathode and anode to complete the electrolytic process. So the nickel, similar to these metals, nickel can be extracted and purified because nickel is a corrosion resistance. So that is used to prevent the corrosion on iron. So nickel must be extracted from the alloys or impure materials, and it is actually carried out through electrorefining process, right? So electroplating and electrorefining process actually both are the application of the electrolysis in electrochemistry, and actually they are the part of the electrolytic cell where oxidation takes place at the anode and reduction takes place at the cathode. And depending on the oxidation and reduction, metal can be deposited onto the cathode or it can be extracted from anode, and which is ultimately deposited on the pure cathode. So these two actually applications, that is electroplating and electrorefining is most important in the electrochemistry, and that must be uh, understood through a proper selection of the metal and electrolytes, right? And through the knowledge of the electrochemistry, we can apply in a various kind of industries, through the process of electrolysis. So I think the concept and ideas behind these two topics uh, actually will give you more insight to understand the electrochemistry of these two topics. Okay, so if you face any kind of problems and actually challenges, then you can directly contact with me and we'll try to resolve your problems. So thank you. In the next video lecture, we'll try to give you more insight on Nernst equation, electrode potential, and standard electrode potentials. Okay, so thank you, student.